Hi everyone and welcome to BIOB20, Introduction to Computational Biology. In this video I would like to show you how to download R and how to get started with using the random number generator. To install R, head over to your favorite search engine and look for RCRAN, C-R-A-N. It should be the first hit, the Comprehensive R Archive Network. And the address should be https://cran.r-project.org. Now you have three options to download from. Choose the one that corresponds to your operating system. For example, I'm on a Mac, so I'm going to choose Download R for Mac OS. Then you should see the top link, and at the time of recording of this video, the version is R421. For you, it may be a later version. Just download the link that corresponds to the latest version here. Click on the link and follow the instructions for your operating system. When R is installed, start the application and it should look more or less like this. When you start the console, you have a welcome message that depends on the version that you have installed, and you have a sign at the bottom that is called the prompt. It invites you to type something at the command line. R is a programming language which is primarily about mathematical operations, like 1 + 1 or 2 × 3. As expected, you get the results 2 and 6. You also get a 1 between brackets, but we're not going to focus on this for now. We're just going to ignore it. The thing that we would like to study today is the function that is called sample. We are going to use it as a thread to get through this demonstration. If you just type sample and press enter, you can see a long list of gibberish that doesn't mean anything. It won't help us understand what's going on here. When you have a new function and you would like to learn something about it, there are two ways that you can get this information. The first is to use the question mark followed by the function name, like sample in this case. When you press enter, this summons the help page of the function sample. You have the title of the help page here, explaining what the function is about, a short description of what the function does, and more importantly, you have the usage of the function. It shows how you should call the function, what the parameters are, like x, size, replace, and prob. You also have another function which comes together with sample, which is called sample int. We're not going to pay attention to it today. Then you have the description of the arguments and the details that explain what the function does. You also have some references in case you're interested in going deeper into the algorithms. And finally, you have a couple of examples at the end that you can reproduce. This is very useful to have some information about a particular function you're interested in. The second way to get the same information is to use the function help. In that case, it summons exactly the same page with the same information. We're now going to play along with the function sample, and the first thing that we're going to try is to just see what happens when you say something like sample with parameter x equals 10. The output is 4, 10, 9, 3, 2, 8, 7, 5, 1, 6. What is interesting is that if we call the function again in the same conditions, we get a different output. You can see this even if the function called is exactly the same, we get a different output here. Sample is a so-called random function. It means that it is connected to a pseudo-random generator, meaning that every time you call the function, you get something different. We can keep calling the function again and we always get a different result. It's because the output is random, or pseudo-random. And because it's pseudo-random, we can fix the state of the randomness so that we can reproduce the same exact random sample. For this, we need to fix the state of the random generator. The way we do this is that we use the function set.seed and we choose our favorite seed 1, 2, 3. When you tap enter, nothing happens. This is a function that doesn't do anything visible, but it sets the state of the random generator so that you can always get back to that state. You can see that once you have set the state of the random generator, when you call the function sample, you get a different output. But if you reset the state of the random generator back again to the same number, then calling sample gives us exactly the same output. This trick of using the function set.seed will allow us to share exactly the same randomness between participants. This also allows you to get a reproducible random sample that other researchers can work on, so it's going to be easier for them to understand or reproduce what happens in your random sample. It is important to understand that the numbers are still random. We can reproduce the random numbers because we chose the seed, but to anyone who does not know the seed, the numbers are completely random. When we keep using the function sample, we can see that we keep getting new values afterwards. We're not stuck with the first value that we got. It's just that at the moment we set the seed, we fix the state of the random generator, and after this, the random generator keeps producing new numbers. You can see that from this point, the sequences that we get are always exactly the same. So to repeat, using setSeed just resets the state of the random generator. After this long introduction, we can try to understand what the function does and how this can be helpful for us. The first thing is that when we call the function with x equals 10, we get a random arrangement of the 10 first numbers, which is called a permutation. But you can see that each number is present only once. What about if we want to allow repeats? If we say replace equals true, writing true in capital letters, then we will start to observe repeats in the samples. For example, the number 10 was present 2 times, the number 7 was present 4 times, and 9 was present 2 times. So replace equals true allows you to draw the same number multiple times. Another thing that we can do is to say that we want more than 10 numbers. For example, we could say size equals 50 to get 50 numbers from 1 to 10. You can see that we get a list of 50 numbers that are all from 1 to 10, and because there are 50 numbers, many numbers are repeated, of course. You can also try to do the same without replacement. Let's see what happens if we remove replace equals true. We get an error message written in red so that we don't miss it. Also notice that nothing has happened. There is no output. The error says, cannot take a sample larger than the population when replace equals false. And of course it makes sense. If we have only 10 items in your sample, and you want to pick 50 of them without replacement, then you won't be able to do it. As soon as you have drawn 10, you won't be able to draw more. And this is why R complains. So remember that when you use a size that is larger than the sample, you have to use replace equals true, otherwise it's not going to work. Now let's see if we can sample something else. Let's say we want to sample between 0 and 1. We see that if we say x equals 2, we get the numbers 1 and 2. But what we want is 0 and 1. We can feed in the function sample anything we like. The function to create a set of values is C for concatenate. When you put C 0, 1, you create what is called a vector with 0 and 1. It's got two values, 0 and 1. The 1 that is here in brackets is an indication that the very first value has index 1, or it is in position 1 of the vector. To give another example, if I want a vector with the values 0, 1, 4, I do C, 0, 1, 4. Now how do I sample between 0 and 1 multiple times? I need to say x equals C, 0, 1, and say size equals 10, for instance. And then, of course, I need to say replace equals true. You can see that this generates a sequence of 10 numbers, 0 and 1, that are repeated multiple times. This is it for today. Good luck with the quiz, and see you in class.